This part is in relation to exercise 16 on page 15. That's still in chapter 1. And the exercise asks us to compute this expression for complex number w in two different ways and try to see if these two computations could help us identify the value for cos pi on 12. Right, this is a simple question, and it's basically all about the way we do multiplicative operations with complex numbers when they are given in exponential form. This is something I'm going to remind you quickly here. If I have two complex numbers, z and w, given in the exponential forms, like so, then if you multiply these two complex numbers, so basically you just multiply the absolute value or moduli of these two complex numbers, and you add up the arguments here. So you multiply the moduli and you add up the arguments. Similarly, if you divide two complex numbers given an exponential form, you divide moduli and you subtract the arguments. All we have to do, we just have to follow this identity first. So, yes. In order to do that, first we have to identify, we have two complex numbers here, that's the first factor, and the second factor. For each of them we have to identify their respective exponential forms. I'll shift it left a little bit, like so. By the way, I have this little diagram, and on this diagram you can see these numbers right away. For instance, this is a number 1 plus I, so this is real part of that number, and that's the imaginary part of that number. By looking at this diagram, or in fact by doing a simple computation, you can see that the absolute value of this number is just √2. So if you look at this number, 1 plus I mean the first factor, this first factor, then you just factor out the absolute value of this number, √2, that's the remaining part of it. And in this remaining part you can identify the standard values for cos and sine. Here they are, so that's your absolute value. The real part is cos of pi and 4, and the imaginary part is sine of pi and 4. In fact, you could just guess, you could see this angle right here in this diagram right away. That's the pi and 4 angle, 45 degrees. So that's the trigonometric form of this number, or equivalently, this is the exponential form of this first factor. Now we do the same trick for the other factor, and this other factor is pictured here. 1 take I √3. It has the same real part, and that's its imaginary part. You could probably guess the angle, but we can do it formally. So first we identify what's the length of this, or modulus of this complex number, and that's a simple Pythagoras type expression, and the modulus is 2, root of 1 plus 3. And so if I now factor out this modulus we found, the remaining part will look like this, and in these values you can identify the sine and cosine of the standard angle. Here it is. It's the angle negative pi and 3. So that's the angle negative pi and 3. That's the angle I'm talking about. Great. So you can, that's your second number. It's your second factor. You can write this factor, of course, in exponential form too. Now you can multiply these two. Let me just roll it up a little bit. Maybe just zoom out too much. I'll roll it up a little bit. If I multiply now these two factors, here's my multiplication. So if I go for the number w, I multiply first absolute values. So I multiply this √2 with this 2, and then I do the exponential and I sum the arguments, pi and 3 and negative pi and pi and 4 and negative pi and 3. Here's my expression. You can do the arithmetic here quickly. It's a very simple one. The result will be negative pi on 12. The result of this bracket will be negative pi on 12. And that's this red vector here, that's the one which represents the number w, with the argument negative pi on 12, and the length of this red vector is 2 times √2. we have just computed the value w using exponential forms. Now if you look down at this exponential form we found for the number w, and if you by using the Euler formula, if you now break it down trigonometric form, it will be in the position of the real line, you will have your cos of negative pi and 12. In the position of the imaginary part, you will have your something. Actually, I put dots here because it's irrelevant for this question. What I'm going to do, in fact, is this. I'm going to take this trigonometric form, or incomplete trigonometric form. Well, you know what's supposed to be here, but I'm going to write this. I'm going to take this incomplete trigonometric form, or actually the real part of this trigonometric form, and I'm going to equate this to the real part of this expression computed directly. But directly, the real part of this number is, look at this, when we multiply this one with this one, and we multiply this I with this negative I root 3. That's the real part of the number w computed directly. And again, for the imaginary part, I just leave it like so. Now, it's the same number w here, in here, computed two different ways, and the real part of this number w computed in two different ways, one here and one here. If you now equate these two different results for the real part of the number w, you will find this cos pi and 12 we need to find in this question, and that's the expression. The reason I dropped the negative sign here, of course, is just because the reason I dropped the negative sign here is because the cos function is an even function. That's why I can drop the negative without changing the result.